Y'all know the drill. Same thing every day. Get those notes out, turn to the right page. Take a look at your do first. Not the top of page 8. You don't need to start on that problem from yesterday. Look at what's up on the board. You're looking at the part right down at the bottom. This problem is solved for you. Right now, as your do first, I want you to silently try to figure out what this student did, starting with the original problem. What did they do line by line? I want you to examine their work, see if you can analyze it and figure out what they did. This is what we're going to be doing today, but instead of me modeling it to start off with, I want you to analyze their work and see if you can figure it out, okay? All right, trying that while I take attendance. Israel.
Here.
Felix.
Here.
Edith.
Here.
Eli.
Here.
Dahlia.
Here.
Stephanie's here. Diego.
Here.
Jamie Lynn. Sandy.
Here.
Brandon.
Here.
Brian. Juan Carlos.
Here.
Martin.
Here.
Nen.
Here.
Kennedy.
Here.
Giselle. Leo. Gustavo. Lirio.
Here.
Tyler. Melanie. Lazaro.
Here.
Jonathan.
Here.
Messiah.
Here.
Joanna.
Here.
Kevin.
Here.
Ehong.
Present.
Christina.
Here.
Johnny.
Here.
Luis.
Here.
Deanthea. Brian.
Here.
Thank you. Does anyone else also have, I know some people got their tests late, so they were doing corrections for me later. If you have any of those things to turn in, just at some point, leave them in my inbox. Just a reminder for anyone that has a late problem set they haven't turned in, or corrections, if I gave your test back late, okay? I'm gonna give back a few problem sets that I got from people late. Y'all keep on working for a few more minutes. All you're trying to do is identify what they changed line by line and write down what you notice. Yes. Keep going, buddy. Thanks. Okay, let's take a look, see how we feel about this. So, from the beginning, we start with this equation. If you walked into class today and you didn't have this class, we do not have any skills yet to solve a problem like this, okay? Anything that might be like tempting for y'all, like I had some common mistakes last year that people did. Anyone, if I said solve for x, what would y'all maybe try to do if I gave you an equation that looks like that? Any ideas? Would anyone like try like dividing, like divide by 6 or something like that? I had a lot of people last year that were trying to like divide by 6 and do things that they normally would move around with solving equations. The issue is in this equation, you're not multiplying times x. X is your exponent. It's like stuck up on the roof right now. We've got to find a way to like get it down, right? Because it's not our base, it's our exponent. Okay, so this is the issue that we're going to try to resolve today. When we're solving exponential equations, we need some new methods for solving to get this x out of like the exponent. Okay, so let's take a look at what this person did, because this is what we're going to be doing today. So let's notice if they started with 36x to x plus 1 equals 6 to the power of x plus 6, what did y'all notice? Any observations about what they changed in this first line right there? What did they do? Christina?
They
Yeah, they rewrote it. It's still 36, right? But they just rewrote it as what? 6 squared. So they rewrote 36 as 6 squared. So the question though is, why do y'all think they chose to rewrite 36 as 6 squared instead of like some other way to rewrite 36? Lirio?
To have the same base.
To have the same base. Notice we have a 6 over here as our base. The cool thing today, we're going to notice that if we can match our base, some great things start to happen, okay? So they rewrote it with a base of 6 so that it matched the other side. So I'm going to go ahead and write down here. You can add on to whatever you said about 36 and 6 squared. Go ahead and add on that the reason they did that is so that they would have a matching base. If you didn't already mention something about that. That's that whole 36 is equal to 6 squared thing, but they wanted 6 as their base. Okay? In this next line, what do you notice they did next? Giselle, what do you see? In 2, from step 1 to step 2, what did they?
The exponent was distributed.
Yeah, this 2 and the x plus 1. Remember when you have exponents like that, you multiply them? And if we multiply, we're going to distribute the 2, and you get 2x plus 2 as that exponent. Alright, then the magic really starts to happen. Line 3. What magically disappeared? Lazaro? Didn't, so be careful, they didn't divide the 6's, because again, dividing a base, like same thing, then they could have done that from up here, and we talked about you couldn't divide. What happened? Not sure? Okay. You're close. I see what you mean, but I want to be specific with like our language. Melanie?
6 has been subtracted on both sides.
Okay, did they subtract the 6's? Okay, so they didn't divide them, they didn't subtract them? Aww. Aww. Ehon?
Times each side by log 6.
You could totally throw some logs in there. We're going to do that next week. So next week we're gonna do solving with logs. Specifically, we're gonna do that a lot when you're gonna get to some examples next week where this would be like 37. Could I have rewrote 37 with a base of 6? No, so like what Eon's talking about with logs is gonna be what we're gonna do next week. This person actually didn't have to deal with logs. You could, you'd get the same thing. But technically right here, all they have, like this 2x plus 2 is what? What part of this? It's the exponent. The x plus 6 is what part of this? The exponent. What they really did is they just set the exponents equal to each other, and they knew that was true because think about it. If I've got 6 to some power, and then I've got 6 to some other power, what has to be true about those exponents for the whole thing to be equal? They have to be the same, right? Like if this was 3, the only thing this could be 3, right? Those two things have to be the same. And so whenever we have matching bases, we can basically then set exponents equal to each other. So the 6's are going to go away. The bases we can like disregard, but not because we divided by 6 or subtracted 6. It's tempting to say that because that's what y'all did when you used to like solve equations with your x's as like bases. But we are just saying that our exponents are the same, so we don't have to think about our base of 6 anymore, right? Okay, so then we solve like a normal equation. You're like moving things from one side to the other, combining like terms, all of that stuff, and we end up with x equals 4 as our final answer. Okay, so I'm not going to go through that last end. But in summary, they made matching bases. If we can find matching bases, then we can set our exponents equal to each other. If we can't, preview to next week, Ehong says we're going to have to use logs and some things like that to figure out how to solve something like this. Unfortunately, you got to use the logs. You can't just divide or subtract by your base on both sides. Okay? Cool. All right. So let's go ahead and get that down. Math joke for today. It's a good one. I hope you appreciate it.
Oh my.
Ehong's smiling. You even liked it. All right. Got it. Polynomial.
And it makes more sense because you're Snow White.
Oh yeah, it kind of works with the theme of the day. But those are dwarfs, not notes, but they kind of look like, it kind of looks like
They look like
sleepy and bashful. Quick, can anyone name all 7 dwarfs? No, raise your hand, because then you're not shouting. No one? Alright, work on it at the end of class, really quick. If someone has it, then I will let you get something out of my prize box. Okay, let's go.
Look at it.
We're on a Wednesday, so I gotta go quickly. No more dwarf talk. Thank you. You can silently be thinking about it in your head and tell me at the end of class. We get out at 12:05, so we're gonna be moving today. This is a small little trick because the main idea for solving is going to be using logs later. But today we're just going to get a little preview of how we can do it with matching bases if it's that type of situation where we can make that happen. So what we're basically using when we're doing this is a property called the one-to-one property of exponential functions. Flip to the top of the next page. What that property says is that if b, as long as b is bigger than 0 and it's not equal to 1, if I have b to the power of x equal to b to the power of y, then what do I know must be true about x and y? X has to equal y if it's the same base, right? Okay. Using that, anytime you have a situation like this, 3 to the power of x equals 3 to the power of 5, you know that x must equal 5. So we can use this to basically solve for x when x is in our exponent, okay? So let's take a look. If you rewrite an exponential equation to have matching bases, let's write down our key idea so that we can come back to it if we need to in the future if we forget this. I don't know where my clicker went. Oh well, too bad. Oh, found it. Thanks, Leo. Leo stole it. Okay. If we have an exponential equation and we can write it to have matching bases, then what do we know about our exponents? They're the same. They're equal. So we can write down the exponents will be equivalent. That's another word for the same or equal. So we can solve by setting them equal to each other. If we can rewrite an exponential equation to have matching bases, then the exponents will be equivalent, and you can solve by setting them equal to each other. Wonderful. Let's do one more together since you actually haven't done one yet. We just looked at their work. And then y'all are just going to practice this, okay? So first up, I got 16x plus 3, 4 to the power of 4x plus 7. My goal is to have matching bases so that I can set the exponents equal to each other, okay? Looking at this 16 and this 4, right now, Dahlia, right now, do these have matching bases? Okay, so I can't set the exponents equal yet. First, I have to rewrite this with matching bases. Anyone out there in the crowd got an idea? Brian does. What do we do? 4 as our base, because I can rewrite 16 as 4 to the power of 2, right? To the x plus 3 power equals 4 to the power of 4x plus 7. I should not have changed anything. Notice, I did not square the 4, because then I would have changed the problem and literally just made that side bigger. Did I make this side smaller? It's still 16, it's just rewritten differently, right? Okay. So notice, don't square the 4 and say, oh, I have 16 on both sides. We want to rewrite this one as 4 squared, okay? Now, what do I have to do with this 2 and the x plus 3? Distribute 4 to the 2x plus 6 equals 4 to the 4x plus 7. Dahlia, now do I have like bases? Yes! Woo! So once I have like bases, I can take my exponents and they are equivalent or equal. So I can solve this equation where my x is not an exponent anymore. Now it's just a regular x, and we know how to solve an equation like this. So go ahead, finish solving this. Then I want you to go straight on to the next one. The next one should be very similar. So I want you to try this out, okay? Solve this one, go on to the next one, then we'll check both answers. We'll come back together to talk about the third one because it's a little trickier. So if you change this, you're only changing one side, this is no longer equivalent, right? Like anytime you have an equation, whenever this is like 2x and 4 or something, like I could multiply it times 2 over here, but I would have to multiply times 2 over here, right? So I can't just change the problem, I have to keep it literally the same. The only way to keep it the same is to rewrite this one, because nothing has changed. I got 7 plus 4x, 4 equals 3, 4x, and then the 16. I didn't add on anything, I just rewrote it. Okay?
I tried doing that for the first problem and I kept getting negatives.
Yeah, and you guys, so it's different, right? If you just change the problem, then you're like, why don't you get that? Okay? No problem. That's it, and then go on to the next one. Perfect. So then you're going straight on to the problem right below, very similar, trying the whole thing on your own. And then the third one at the bottom is a little trickier, so we're going to talk about that together in a second. Lovely. Lazarus already got it. Lazarus, would you like to check people? Or you want to go on a third? Okay, he's going to keep going. Good. Go on to the next one. Lovely. Leo, let me see. Lovely. Okay, so you can think about this one. Oh, wait, check this guy. You're close, but not right. 2x plus 6 equals 4x. Lost your 4. How many out of here? Go. Okay, good. So you could square it, but then you want to flip it, right? So if you want to square it, then it's going to be to the power of 2, right? But if I want 2 to the power of 2 to go to the bottom, then it's going to be a -2. Because 2 squared would be 2, and so it would be 4. So you're going to rewrite this as 2/3 to the power of -2, because 2 squared is 4, and a negative would send it to the bottom. 3 squared is 9, and a negative would make it go to the top. Okay? Remember, negative. Lovely, very good. Okay, I see most people finishing up the second one. Finish up if you haven't already. Let's check it. You got it, yep. Okay. Check your answers if I haven't already checked them off. For this one, it was -1/2. For the next one, I believe you end up with the equation 2x plus 14 equals 18 minus x. And then when you solve it, you'll get 10/3 or like 3.3 repeating if you're it as a decimal, but you can leave it as a fraction like that. Okay? Cool? Okay. Next one, I got a lot of people off to a great start that already think they have an idea of what to do. But I want to kind of join back together because this one's a little bit tricky. So when we're looking at this, one, there's a fraction. If I had 2/3, and then let's say on this side I had 4/9, what are we trying to do to both of these? What? Again, we're trying to match the bases, so we're not trying to find a common denominator, we're trying to match the bases. So would I be trying to square it or cube it, or what would I have to do? Squared, right? Like 2 squared is 4, 3 squared is 9. So I could rewrite this as 2/3 but squared, and that's like 4/9, okay? What's the issue though when you look at this one? It's like almost that, but not. So raise your hand if you can tell me what the problem is when you look here at what we have. Lirio?
The 9 is on top instead of the bottom.
Right? We don't have 4/9, we have 9/4. So that means what we have on the top, we want to be on the bottom. What we have on the bottom, we want to have on the top. Okay? So we're going to be very similar. We're going to leave this one. We're still going to rewrite this one with a 2/3 like this because we want to have matching bases. Except we can't just square it. Well, how can we make it squared but also flipped? What can we do?
Negative.
A -2. Remember we said negative exponents sends the top to the bottom, and so it's also going to send the bottom to the top. So 2 squared is 4, but that's 4 on the bottom. 3 squared is 9, but that's going to be 9 on the top. Okay? So this is how we're going to rewrite the 9/4, and then that is raised to a power of 3x/4. Cool? Okay. Same as before, you're not really distributing because there's not 2 terms, but you're still multiplying here. Quick note about multiplying fractions. I've seen a lot of people today that have done -6x/8. They multiply times -2 on the top and the bottom. When we multiply fractions, think about this as -2/1 times 3x/4. When you multiply fractions, you just multiply the tops and you multiply the bottoms. So -2 times 3x is what? -2 times 3x, -6x over 1 times 4 is 4. Okay, so just be careful with that because I had some people today that were writing that as -6/8. You only multiply -2 on the top. Okay? Do we have like bases? Woohoo! So what can we do? When we have like bases, what can we do with our exponents? Set them equal to each other. Okay? To solve this, thoughts, raise your hand, you can tell me what you would do next. Hands, what would you do next? I already heard from Lario, someone new. Brian.
What's about 4?
Good. If you multiply times 4, again, just be careful because we're multiplying that whole thing times 4. So we have 4x minus 20 equals -6x. And then I'm going to leave it for y'all to finish from there. In about 30 seconds to a minute, I'll put up the answer so you can check it. But what I want you to do is go on to the back once you're done. There are 7 problems for you to practice in our last 9 minutes. That's a lot of time to practice this. Notice some of them on the back, you might actually need to find a different base on both sides if you can't match the one that's already there. So I put up here my little power poster to help you look for like the key numbers if you're like, 32, what? Oh, 32 is 2 to the power of 5. So you can use this to help you, okay? Okay. Finish solving this and then head on to the other side. I'll show you this answer in like 30 seconds once you have a second to finish. Okay. So again, we are just trying to rewrite 9/4. Just like here, 7 squared is the same thing as 49. So in here, we want to have exactly what we have in here, except this thing in here has to match whatever's over here, right? What's over here? 2/3. Okay, so our goal is, how can I write 2/3 to be equal to 9/4? Okay? First thing is that I want to square because I want 2 times 2 is 4, 3 times 2 is 9, right? The second thing is that I don't want the 9 to be on the bottom.
Positive, so you're
Right, and to be on the top, which means that you're negative, which means that you're So this is literally equal to 9/4. That's when you're doing, yeah, that's when you're dividing fractions. So what this means is, where, like, if I give you this problem, what would you do? How do we solve that?
Did we
Not
already
sure.
hit?
I think
If
it's
you
still
square both of them,
anyway, but I don't
but
know
then
if it's
whatever's on the bottom goes on top, top goes on the bottom, goes in the negative. So 1 squared is,
the mark.
1 squared is 1, but that goes on the bottom of the negative. 3 squared is, and that goes on the top.
She does la chancleta like this.
Because 1/3 squared is 1/9. So 1/3 of -2 is -1.
Oh, okay.
That's not anymore.
You have
You're
to find like their own exponent, like 2 to the power 2 will equal 4, and then 2 to the power 3 will equal.
So basically, 9/4, anytime you want it to be the opposite of what it is, you can use like a negative exponent.
The benchmark.
How are y'all doing? Good. So you use 2 for both. Good. Geniuses in here. Okay. Are we still going to the, okay. So this is, yeah, so this is tough because I can't right here write this with a 4. Right, were we struggling with writing this as a 4? Yeah, thank you. I saw Diego, you had this as 4x plus 7, and you were trying to make this a 4. But 4 squared is already 16, like this doesn't work. Okay, so we can change, before I released you, I said, don't worry, because sometimes if you can't match it, you can still match it, but just with another base. So let's think, is there a way we can write
The 4 on
4 and 8, does 4 and 8 show up in any of these columns where I've got the same base? 2, right? 2 squared is 4, 2 cubed is 8. So in this one, I have to rewrite both of them. I can rewrite this one as 2 squared to the x plus 7, and I can rewrite this one as
You can
2
also put this in like
cubed to the x plus 3.
and they will have the same.
It's still the same base, right? It's just not a base that I was started with from the beginning.
How come you just don't square, cube the
It's
4?
always-
If I cube the 4, 4 times 4 times 4 is 64. But I cannot cube or square things. I want things to literally stay equivalent. Whenever I like cube this side and square this side, I'm not doing the same thing on both sides. It's no longer equal.
For what?
Right? Like I can't just change the problem. Here, I'm not changing the problem. What's this still equal
There's no
to?
way you can get,
Right? I didn't like change it and like make it bigger. It's still 4. This is still 8. It's just rewritten differently. Okay? So notice here we didn't square the 4 and make this 16, right? We didn't make it bigger. We didn't change the problem. We rewrote
Oh, yeah,
16
I forgot to
as
distribute.
okay? So we can't change the problem and start squaring or
But
cubing.
literally, you
We're
said it.
rewriting this as
We'll distribute it to number 7.
Smaller coefficient?
so then I have
Hold on.
2x plus 14,
So it's like
3x plus 9, and so I'm going to set those equal to each
the
other.
most common smaller coefficient.
Base. No, not coefficient, but I know what you mean.
Oh, yeah,
It's the base.
Base.
Yes, ma'am. You have 4 minutes. See if you can finish at least 3 of these. 3 out of 7, if not more. This is going to be your goal. So now distribute. And then set them equal to each other. Lovely. Try another one. That's perfect. I'll go ahead and put up the answer for the first one so you can check it. Again, I want you to try to finish at least 3 before you get out of here. Yep, you could use 2 for both of those. Notice both in the 2 column. If I use 2 as my base, I could do 8 because that's 2 cubed, and 2 to the 5th power would be 32.
Oh, okay.
Okay.
yeah. No, but like the second grade cycle. Just 8.
Okay, cool.
You don't have to fail, you just have to not get accepted to college.
How you doing? Good? This one on the bottom though, we don't necessarily need it to flip, right? They're the same, like I just want you to write this as 3 over 4, but square root. Oh, plus
Yeah, because I think you can.
Yeah,
Yeah.
very good. Awesome. Okay, so same thing with this one. I can't write this with a base of 8, because 8 squared is already 64, it's not 32. So again, I'm looking probably to use 2 for both of them, because I've got 8 and 32 in this. So I can write 8 as 2 cubed, and I can write 32 as 2 to the 5th power of 32. Okay?
With X, right?
Okay, y'all, since we got 1 minute left, I'm gonna go ahead and put up the answers to all these so that however far you got, you can check them. And then if you feel like you need more practice with these, there's 2 on your problem set, or you could finish any of these if you wanna jot down the key right here, okay? Which one does that? So your equations, let's jump to the equations. So then 3x plus 11 equals 4x minus 14. So that is your equations before you solve.
Everything is senior.
3x plus 11 equals 3x plus 11 equals 4x.
Be anything without
You did this right. So this should be alright, y'all, see ya. Kevin, can you turn up the Brandon, do you leave your notes or, sorry, I saw you leave yours.